Hello, Tom from Every Step Calculus. This one's problem number 6, where the x squared is in front of the square root sign. If you've seen other videos, I've explained quite a bit about these right triangles stuff, useless stuff. My main menu, getting to u-substitution. Enter the function. Press alpha first. I've already entered the characters in here, the variables, for a quicker video, shorter video. So give you a chance to change it in case it's not correct. I say it's okay. Again, I show you where the a squared is, which is the square part of the problem. All these 9s, there could be 16s, 25, 4, could be 1. And we set up the problem by making x equals a times secant of theta. We've done that before in the other ones. Differentiate both sides, which turns out to be a secant tan theta. X squared equals a squared times secant squared of theta. Now notice that other programs I might have had u in here, which a lot of times the books have u, but it's still the angle. This one I use the theta in there. And so the square root of x squared minus 9, if we substitute for x squared, we get a squared and secant squared times theta minus a squared. Of course, we factor out the square root of a squared, which is a. Here I keep it square root of a squared and secant squared. This is an identity, secant squared minus 1. And the identity is tan squared theta. And so then the square root of x squared minus 9 is equal to a times tan of theta. So now here's the original problem again. We're going to substitute for x squared that we found, and we're substituting for square root of x squared minus 9 that we found. That turns out to be a squared times secant squared of theta times a times tan of theta, and then here's the dx up here on top, secant tan theta d theta. So it turns out to be 1 over, they cancel, many of those things cancel, so we have a squared times secant theta, and of course this is a constant, 1 over 9, so that comes out of the integral, and we have 1 over secant theta. Reciprocal identity is cosine 1 over secant theta is cosine of theta. The integral of cosine of theta is sine theta. Okay. So in a right triangle we have secant of theta equals hypotenuse over the adjacent. Okay, so that's the hypotenuse in this case is x, and the adjacent side is a. In other words, you have the right triangle like this, and the hypotenuse up here is x, and the adjacent is a here. And so the opposite side is the square root of x squared minus 9. Sine of theta equals opposite over hypotenuse, so equals the square root of x squared minus a squared over x. So the answer is 1/9 times square root of x squared minus 9 over x plus c. Now notice that when you integrate, it's the area under a smooth curve if you have the range or limits to it. And in this case it's an indefinite integral, so we have to somebody has to find out about c and put in there. And notice that if they did that, then you'd have the area under this some sort of curve. There's no curve in a right triangle, so In that case, they would call it a line integral and tell you that it's the mass of the hypotenuse line or some baloney like that. But, so keep that in mind, and notice that no matter when you put x in here and you get the number, if you wanted to throw in some c, you'd get a number, okay? So notice that nowhere in a calculus book does it ever say, you know, square increments of what you found, you know. So calculus really, in my opinion, doesn't solve anything useful, you know. It's a waste of time. It's a series of extremely hard puzzles that you're supposed to solve and feel good about it because you, and of course you will feel good if you pass your class and never to take it again. So calculus to me never solved anything at NASA or space or anything, you know, like they suggested it does. And I would like to see a model of something that did do that, you know, if I wasn't correct in that. But I've studied calculus so much, even more than doctors of mathematics. I know calculus, okay? And when you 25 years of programming every single character in a problem step by step, you learn what it can do and what it can't do. Notice in this case we have 9 minus x squared, and look at the difference in answers. And the answers are more complicated than the function. And of course the function holds all the information in calculus. If it's not in the function, calculus will not pull it out of it, you know, such as velocity or acceleration that they brag about it that it does. So anyways, buy my programs, $40, and you don't have to study all this crap. You can use your calculator, and if they allow you to use the calculator in class, use the calculator. Put in my programs and use the calculator. What's wrong with that, huh? So anyways, have a good one. Good luck in your classes. See you later.